Hi friends, welcome back to Smart Engineering Academy. Myself Amit. I am here with a continuation of part 4 of my video. So in the previous video, that is in the part 3, while calculating the effective length, due to some technical problem, I was not able to explain it properly. I'll just explain it again. So let me start from how to find the effective length. I think up to how to find the effective depth, everything is clear from the previous video. So let me start the session from effective length. Fine. So this would be the beam and this is the clear span. I need to find the effective length. So L effective is equal to, we have two formulas for this. Okay, one is length of clear span plus effective depth, then length of clear span plus width of the beam. Okay, I just take it as B or W, whatever it may be. We need to do the calculation of these two things. I need to take the value of the minimum of these two things. Okay, let us see. So what is length of the clear span? That is 8. It is in meter. I'll convert it to 8000 plus what is the effective depth? Effective depth is 48. Sorry, effective depth is 452. Okay, I am just writing here. So second formula is same, 8 into 1000, that is length of the clear span plus width of the beam. You can see here, this is 500 is the width of the, sorry, not 500, 230 is the width of the beam. Okay, this is width of the beam. So I'll get a two answer. One is 8452 and other one is 8230. Which one I need to consider? I need to consider the lesser value, that is minimum of these two values, that is 8230. So the important point here comes is how to substitute, so that I need to, okay, one thing is that I need to add here the two formulas, but I need to get the minimum values from those two. So let us see how to do it. Fine, I am just coming here, I am pressing equal sign. Okay, now to find the minimum, the cheat code is minimum, MIN, minimum, we'll get here. So take this, okay, open sufficient brackets. I'm opening is two brackets. Okay, the first formula is clear span plus depth. Okay, I'm just going into clear span. I'm clicking upon this clear span. So it is in meter. I need to convert it into mm, so into 1000. I'm just closing a bracket. Okay, one more thing what I want is plus, what is this, D, effective depth is this one. Okay, I'm just closing one more bracket. Okay, so I am again putting comma. This plays very important role. Okay, either it need to take minimum of these two values, has to be bifurcated using the symbol which is called as comma. Okay, and again I am opening the two brackets. Then clear length, that is 8 into 1000. Fine, I am closing the bracket again, plus width of the beam. So what is the width of the beam? I am clicking here. I am just closing two brackets, 8230. See, I can prove here that, so there is 8452 and 8230. I got the minimum value, that is 8230. That is a cheat code, which is MIN, minimum of those two things. I need to substitute these two equations, which is bifurcated, that is which is bifurcated by a formula, by a symbol that is called as comma. That comma plays a very important role. This is very important step. So up to here almost all the basic conditions has been done. So the next concept is calculation of loads. Now we are coming into the calculation of loads, that is design concept.